Now, in this lecture, we learn the programming. The first programming, addition program, we will see how to write the programming for the addition. So, if I wanted to add two numbers, so these are the two numbers if I wanted to add, then how to write the program? Now, if you take a high level language program, you will write int a, b, c, and a is equal to 3, b is equal to 2, and c is equal to a plus b. You will write program like this. Now, in the microprocessor, we don't have a variables to assign the values. So we need to use the general purpose registers. And you know that in arithmetic and logical operations, one of the operand must be in the accumulator. Why? Because so this accumulator is connected to the now here ALU accumulator is connected to the ALU, and one more register, temp register, is connected to the ALU. So means what? One of the operand we have to move into the accumulator. So now in this 2 and 3, I have to move 2 or 3, any one of the value into the accumulator. Now what is the instruction for moving the data, immediate data? So move immediate A comma 03H. Now these are the hexadecimal values. Now after moving the one value, now one value is available in the accumulator. Now one more value is two value. Directly I can write ADI. I can add the immediate data 02H. Now this is the program for the adding two numbers. Now after that what? Now result is where the result is in the accumulator. This is one way to write the program. Now another way is first variable I am moving into the accumulator, and second variable I can move into any one of the another register, any one of the register. Now here I have taken the B register. Now one of the value is in the A and another value is in the B. So now I can use add B. Now this is if I'm using two registers. If this is in the case of immediate data. Now after that halt. Now in this case also what data is in the accumulator. This is another way to write the program. But if you see here, if I wanted to test the result for the different values, now this is the program where you have assigned the values to the variables. Now if you wanted to give the values through the keyboard, so scanf you will use. Similarly, here also if I wanted to vary the data, change the data that time, so assigning values like this is not correct. So now I have to store the values in one location. Now if I'm taking one location 6500 location. In this location, I have to move this 03H, and 6501, I can move this second value. Now, if I wanted to change the data, I have to come to this memory location, and whatever the data I wanted to change, I can change here instead of changing the data within the program. Now, again, I wanted to store the result in the next consecutive memory location. Now, here I wanted to store the result. Now, for this, how to write the program? Now, here in the memory location I loaded the data means now this memory location is required to pointed with one instruction, one register. Now here this memory location is a 16-bit address. So needed the register pair. For that what I am using the LXI H comma 6500. So meaning is what? LXI 6 comma 00 means what? Here HL pair. Now this address is moved into the HL pair. So this address is pointed by using the HL pair. Now here if I have taken like this means what? So in the HL pair, now we are moving the 00 into the L and 65 into the H. Now HL pair will point to the 6500. That is the meaning of the instruction of LXI H0. Now the this location is pointed by the HL. Now this we need to move into the now the first location data need to move into now any one of the data should be moved into the accumulator, right? So first data we need to move into the accumulator. Now for that what is the instruction? Now HL pair is pointing to the location. So this location data we need to move into the accumulator. Now for that the instruction is move A comma M, where M is nothing but what? HL pair. HL pair is pointing to the location. Now this location 3 is moved into the accumulator. Now after that what we need to do, we have now HL pair should point to the next location. Now for that what we need to give? Increment X H. Now incrementing H means what? register pair. So which register pair we need to increment HL pair? Why? Because HL is pointing to the 6500. Now HL should be incremented. So this value should be incremented means what? It is point now again pointing to 6501. If we increment the M means what? 3 will be incremented and it will indicate the 4. So that should not happen. Now HL pair should point to the next location means what? We need to increment the HL pair. So it is now HL pair is pointing to the 6501. Now whatever the data is there here, we can add directly like this. Now ADDM means what? So HL pair is pointing to 6501. In this location 02 is there. That 02 is pointed by the register M, and that we are using add M means what? Accumulator content is added with the location content. So the location is pointed to the 6501, and in this 02 is there, that we are adding to the accumulator content, that is nothing but a 03. Now after this what? Again we need to move the result into the next location. What I said, in this location I have to move the result. For that what? Once again I have to increment the HL pair. So thereby what? HL pair is pointing to this location. Now in this now whatever the now result is in the accumulator. Now that I have to move into the memory location. Now after that halt. So the meaning is what? Accumulator is consisting of the result. That result I have moved into the memory location. Memory location means what? HL pair, what it is pointing in this location, we are moving the data. Now this is about the program for the 2 8-bit to 8-bit data. Now, but here one problem is there. This program is applicable only for those operands which are not generating the carry. Now, if I have taken the data like C8 I have taken and D9 I have taken. If I wanted to add these two data, see how 8 how can I write now? 1000. See how can I write 1100? Now again 9 how can I write 0001? D how can I write? D is the value of 13, so 0. This is the value. Now to for adding this, what we will get? 0 1. If you add, you will get 1. Additive properties, you try to recollect the additive properties. 0 0 0 0 0 0 and 0 1. If I am adding 0 and carry will be generated. Now if I add 1 0 and now here 1 and 1 1 means what? 1 0. Now if I add these 3, I will get. Now this is the result. Now if I take the hexadecimal value for this one, this is nothing but what? 10, A, and this is nothing but a 1, and carry is generated. So this is my total result. If I don't consider the carry, my result become A1. So instead of 100 and A1, 1A1, it is showing only A1. So partially we are getting the result. So with this, it is not the complete result. We have to consider the carry also. Now for that we need to do some modification in this program. Then how to write that program? We will see. So to store the carry, now I am taking one more register which I am not using in this. So I am taking the C register, move immediate C comma 00, which means what? The C register I am initiating to 0 so that if carry generates, I'll increment the C register. Now again, in 6500, my data is there. First value is there. 6501, my second value is there. Similarly, 6502, I have to load the sum, and 6503, I have to load the carry. Now, two, two locations I use it to store the data, and two location I use it to store the result. Now here see I have taken for the carry. So whenever the carry generates, I'll increment this register. Now to initiate this addresser, now I am taking the LXI H comma 6500 means what? HL pair I initiated with the 6500. Now after that what I need to do? If HL pair is pointing to this location, now this content I have to move into the accumulator. So for that what I'm doing, move A comma M. Now after that what? HL pair should point to this location. For that I have to increment the HL pair. So in INX, H means what? HL pair value is incremented. HL is holding this value. This value should increment, means what? This should appear, means what? HL pair I have to increment. So this is after completing this one. Now what I have to do? I have to add the accumulator content with the memory location. Now this value, direct memory location value, I am adding with the accumulator. Now accumulator is consisting of what? 0, 3. So after adding, now here I have to check whether the carry is generated or not. So now here I'm using the, after the addition, I'm using the JNC. If carry is not generated, it has to jump to this location. If carry is generated, now this I initiated for the carry purpose. So now I am incrementing the INRC. Now why I have used INR? INR is for the incrementing the 8-bit register. INX is incrementing the 16-bit register. Now HL pair we have to increment. That's why X we use. Wherever X comes, that is for the pair. Now I incremented. If JNC means what? No carry, then it has to jump to here. Otherwise, if the carry is generated, then it will come to here, then the C register will be incremented by 1. If after that what? Now I have to increment the HL pair once again to store the result. Now, if the carry is not generated, then I have to increment the HL pair and need to move the sum. Move A, M, comma, A. So now where the sum is there, sum is in the accumulator, that I am moving into the memory. If the carry is generated, for example, carry is generated, now the C is incremented. So that also we have to move into the next memory location. For that need to increment the HL pair so that it will point to the 6503. In this again, I have to move the, not in the accumulator sum is there, in the C carry is there. If carry is not generated, then the 00 value will be moved into the memory location. If the carry is generated, it will incremented by 1, means what? Now the C holds the 01. The 01 will be moved into the memory location. Now after that, halt. Now this is the program to write the addition program. Whether if you are taking the two values which are generating the carry or not, so this is the program. Now after completing this program, now in this location 05 will be available, and in this location 00 will be available. If we have taken this data, carry is not generated. Otherwise, if you have taken the data, now in the previous example, what I have taken, C8 and what are the C8 and D9 I have taken. C8 and 6501, if I have taken the D9, then in 6502 I will get 6503 I will get the carry 01, and 6502 what value I will get? A1. Now this is the A1. This is the all are hexadecimal numbers. So this is the complete result. Carry is this one and sum is this one. We have to consider along with the carry. So this is the program for the addition.